If I had a pound for every time somebody asked me, "What's a ratio?" then I'd have a ratio. In this video, we will take our first look at ratios. Ratios can be written in many different ways, so we will get you comfortable with spotting them in questions and interpreting what the question actually means. The good news is, once you've done this, the maths is pretty straightforward, and we'll cover a few example questions to show this. At one point in this video, we will take a short intermission to discuss a perfectly powerful word which will help you in many areas in maths. But first, let's start with a simple question. What is a ratio? Well, a ratio is just a way for us to compare the relative amounts of two things. Here's a ratio, 1 to 24. This means for every one thing on the left, we have 24 things on the right. For example, this could be the ratio of days to hours. For every one day, there are 24 hours. As I said earlier, ratios are actually quite simple in terms of maths. The main difficulty lies in the fact that there are loads of different ways that you can write them, so you have to be really careful when you read a question. So let's take a bit of time to look at that before jumping into questions. I'm going to show you that for one actual ratio, there can be 24 different ways to write it. Let's start with a very small zoo. In fact, I went to a small zoo once. It only had one animal. Anyway, in this zoo, we have 2 zookeepers and 6 monkeys. We have a comparison of 2 things here, hence we have a ratio. Let's look at the ways this very simple example could be written in a question. The question might say, the ratio of keepers to monkeys is 2 to 6. This format, with a colon between the 2 numbers, is the traditional way to write a ratio. I'll call it ratio format from now on. The question might just say 2 to 6, or even 2 per 6. We will now have a short intermission to discuss the amazing value of the word per. We use the word per a lot, and it always involves a ratio or a fraction. Let's look at some examples. I got 50% in my test. The car drove at 60 miles per hour. I read 2 books per month. Well, 50% is 50 per 100. The word cent represents 100, like a century having 100 years, a dollar having 100 cents. And centipede literally means 100 feet, even if centipedes don't actually have 100 feet. 50% is 50 divided by 100, which simplifies to a half. So if you get 50% in a test, you've scored half marks. Looking at 60 miles per hour, this means the car travels 60 miles per 1 hour. Miles on the top, hours on the bottom. We just don't normally write the 1. If another car travelled 100 miles in 2 hours, we can write this as 100 miles per 2 hours. Miles on the top, hours on the bottom. Which simplifies to 50 miles per 1 hour, which we would usually describe as 50 miles per hour. Incidentally, if the unit on the bottom is a measure of time, like hours or seconds, this ratio is also known as a rate. But more of that in another video. And finally, if somebody reads 24 books in 1 year, then the amount of books they read per month is 24 books divided by 12 months. So books on the top, months on the bottom, which simplifies to 2 books per 1 month. The thing to notice in all of these examples is that the per thing should go on the bottom of the fractional ratio. So per cent has 100 on the bottom, per hour has the hours on the bottom, per month has the months on the bottom. So if you see a question and you're not quite sure what should go on the bottom and what should go on the top, look for the word per and put that thing on the bottom. For example, if you get a question that says 5 kilograms of flour costs £4. What is the price per kilogram? Well, we have per kilogram, so the kilogram goes on the bottom, so that's 5 kilograms, and the other number goes on top, so 4/5, which simplifies to 0.8 pounds per kilogram. If the question has the same information but asks how many kilograms per pound, we have per pound, so the pound goes on the bottom, which is £4, and the other number goes on the top, which is 5 kilograms. Therefore, we have 5/4, which simplifies to 1.25 kilograms per pound. So there you go. If you want perfect answers, look for the word per and put it on the bottom. End of intermission! So as well as 2 per 6, we can write this as a fraction. 2 keepers per 6 monkeys, and the per monkeys goes on the bottom. Well, that's 4 different ways of writing the ratio. But when you see a fraction like 2/6, what does your inner mathematician say to you? Hopefully just one word. Simplify! Yes, this fraction of 2/6 can easily be simplified by dividing the top and the bottom by 3 to give 1/3. Similarly, this simplification can be applied to the other ways of writing. So 1/3, 1/3 again, and 1 per 3. Right, we're at 8 different ways, and I promised 24. The order of objects in a ratio is important. The question wording might swap the order. So we might have the ratio of monkeys to keepers is. We can't just write 2/6 because that would imply we have 2 monkeys and 6 keepers, which we don't. Hence, we need to ensure we write the numbers in the correct order. So we would have 6 monkeys to 2 keepers, 6/2, 6 per 2, and 6/2 in fraction format. And again, we can simplify these. This becomes 3/1, 3/1, 3 per 1, and 3/1. Now this last fraction can obviously simplify to just 3, and that's fine. But in your head, just remember that we are still comparing 2 numbers. It's just that the number on the denominator is 1, so we don't often write it. Okay, we're at 16 different ways now. These 16 have all been part-to-part ratios, by which we mean the 2 numbers relate to the 2 different things we have. In this case, one number relates to the keeper part and the other number relates to the monkey part. However, some questions might sneak in a part-to-whole ratio, where the second number relates to the total number of things. In this case, 2 keepers plus 6 monkeys means we have 8 things in total. Hence, we might see a question saying something like, a zoo contains living beings made up of monkeys and keepers. And then the ratio would be described in relation to the total number of 8 beings. So in fraction format, the question might say, 2/8 of the beings are keepers, or 6/8 of the beings are monkeys. And in ratio format, these would be the ratio of keepers to beings is 2/8, and the ratio of monkeys to beings is 6/8. And again, these ratios could all be simplified like this. So as promised, there are at least 24 ways to write these ratios. And don't forget, we haven't changed anything. We still have 2 keepers and 6 monkeys. But this highlights just how important it is to interpret the question carefully to make sure you fully understand it before you start solving it. By the way, do you know what this is? You might have just thought it's the ratio 6:30, but actually it's the best time on a clock, hands down. Okay, let's check out an actual question. Given a zoo needs 2 keepers to look after 6 monkeys, how many keepers would be required if a zoo wanted to have 27 monkeys? This is an example of a scaling question, where we are given a ratio and we need to scale it up, or sometimes down, to reach our answer. So first, we need to work out exactly what the ratio of keepers to monkeys is. It's fairly clear in the question that this is 2 to 6. So let's write that in ratio format. It's often useful to simplify, so I can see here that if I divide each side by 2, I have the equivalent ratio of 1 to 3. Now, the goal of the question is to solve for the unknown number of keepers in the larger zoo. We don't know what that number is, but we know that the number of monkeys is 27, and that we need to keep the same ratio of 1 keeper for every 3 monkeys. So we need to scale up our ratio. To get from 3 to 27, we need to multiply by 9. 3 times 9 is 27. So we need to do the same to the other side of the ratio. 1 times 9 is 9. And that's our answer, 9 keepers to 27 monkeys. We could have also tried this question using fraction format. We have our starting ratio of 2 keepers and 6 monkeys. We can then simplify this fraction by dividing the top and bottom by 2 again. And again, we want to solve for the number of keepers when we have 27 monkeys. So what do we have to do to make these equivalent fractions? Well, to go from 3 to 27, we multiply by 9 along the bottom, and we need to do the same across the top to reach our answer of 9. Let's give you one to try. Have a read of the question and see if you can get an answer yourself before watching further. So pause the video now. Did you find that okay? What was your answer? 32? 8? Something else? There are many different ways to do this. I'm going to have a bash in fraction format. At the start of the question, we are told a zoo needs 24 keepers to look after 6 elephants. So we already know that the ratio of keepers to elephants is 24 to 6. I can see that this simplifies because the top and bottom both divide by 6. This gives us the simplified ratio of 4 to 1. We could write this just as 4, but leaving it as 4 over 1 reminds us there are 2 parts to this ratio, keepers and elephants. Now, the question says the zoo wants to increase the number of elephants to 8. So how many keepers will there be? We need an equivalent fraction. If we have 4 keepers per 1 elephant, then how many keepers do we have for 8 elephants? Well, to go from 1 elephant to 8, we need to multiply the bottom by 8. And we need to do the same to the top, which gives us 4 times 8, which is 32 keepers. So, did you get the answer 32? If so, you weren't quite right, and this shows the importance of reading ratio questions, or any question for that matter, really carefully. The question actually asked, how many additional keepers do they need? We know they need 32 in total, but they already have 24, so the additional keepers they need is 32 minus 24, which is 8. Here's an example of a different approach. I'll use ratio format for this one. You might start with the ratio of keepers to elephants and then simplify it to a 4 to 1 ratio. Looking at the question, you might think, the zoo is increasing from 6 to 8 elephants. That's an addition of 2 elephants. Looking at your 4 to 1 ratio, you can see that there are 4 keepers required per elephant, so 2 additional elephants means 8 additional keepers are required. So as I've said, it's really important to read ratio questions carefully. Once you've understood what the question is asking, the methods are pretty easy, whichever one you choose. Well, that rounds off our initial look at ratios. Hopefully you'll agree that the concept of ratios is fairly simple, as is most of the maths involved. It's just that the questions can be a bit risky if you don't take your time to read and understand them. So be careful out there, kids. If you have any fears or questions, just let me know in the comments. And if you found this video useful, then please do see if you can reach a ratio of 1 to 2 for the number of times you've viewed this video to wonderfully nice actions. We have videos covering other ratio topics like simplification, triple ratios and trickier questions, so I'll put a link to those in the description. And please do check out the other videos on Noodle Doodle Maths. Until next time, I'll see you.